Hi, physics. Mr. Janowski here. So this is chapter 13, homework 1, problem 8, and we're going to have to borrow part of the answer from problem 7 to do part of this one. So what's going on here? What is the closest that Mars and Earth get together? A sketch will help. So let's start there with, come on, step, Okay, so the first thing we want to know, I didn't actually label them as A, but the distance, Earth to Mars, is question mark, and what units will it have? It's a distance. It'll have units of meters. So the next part, when this occurs, what is the gravitational attraction between them? So what I should have labeled as part B is force of gravity between the Earth and Mars is question mark, and the units will be newtons, of course. And then the last part is, how does this force compare with the gravitational force between the Earth and the Sun? So really what we're going to want to know there for part C is gravitational force, Earth and Sun. Come on, computer, hurry up. Okay. Gravitational force, Earth and Sun. My computer froze again. So this is an 8-year-old laptop, and I really need a new one. But I've been spending so much money on other things lately that I'm going to hold off for a little bit. So yeah, part C. How does this force compare with the gravitational force between the Earth and Sun? So we want to know gravitational force, Earth and Sun. How does that compare to our answer for part B? Gravitational force between the Earth and the Moon. So that'll actually be a ratio. And that won't have units. So how do we get started with this? Well, it says a sketch might help. So what is the closest that Mars and Earth get to each other? So think about it. If you have the sun here, and then you would have, all right, let's say you've got Mercury here, and you've got Venus here. You would also have the good old Earth somewhere like this. Now, sometimes Mars, which is further away from Earth, Mars will be way over here. But this is not when Earth and Mars are going to be closest. Earth and Mars will be closest when they're lined up. So this guy here. So this is Earth, and this is Mars. So, I mean, really, yeah, this is all step 1. This is a sketch. Very useful. What is the closest they'll get? So I have the radius of orbit of the Earth right here, and I have the radius of orbit of Mars right here. So which one of these numbers is it? And that's a trick question. It's not either of these numbers. So think about what's going on here. This here is radius of orbit of the Earth from there to here. I guess I should keep that. And this here is the radius of the orbit of Mars. So what we're looking for is actually this guy in here. So if you draw the little sketch, hopefully you can see, this is fairly straightforward. This is just the radius of the orbit of Mars minus the radius of the orbit of Earth. So that's what that distance is. So look at my sketch and convince yourself that that's true. So our answer for part A, so let me call it what I called it before. Distance Earth and Mars is going to be radius of orbit of Mars minus radius of orbit of Earth. So check the table. Radius of orbit of Mars, 2.28 times 10 to the 11th meters, minus radius of the orbit of Earth, 1.50 times 10 to the 11th meters. So if you put that in the calculator, 2.28 E11 minus 1.50 EE11, you get 7.80. Why not? Let's keep 3 sig figs. Times 10 to the 10th meters. So yeah, do it in the calculator. You could also just think of this as 0.78. Actually, you know what? That shouldn't actually be there. I'm not going to tell you why, but that shouldn't be there. You could also think of it as 0.78 times 10 to the 11th. So both of those things are equivalent if you want to keep it in 10 to the 11ths. But anyhow, yeah, that's the difference between other distances. So that's our answer for part A. For part B, let me pick a nice color for part B. All right, for part B, we want to know the force of gravity between the Earth and Mars. So that's going to be big G, mass of the Earth, mass of Mars, divided by that distance between them, distance between the Earth and Mars squared. So divided by our answer for part A squared. So what do we have? We have 6.67 times 10 to the minus 11th. Yep, that got messy. 10 to the minus 11th, and I'm going to leave off the units here, times the mass of the Earth. Okay, the mass of the Earth, come on, slow computer, is that number, 5.97 times 10 to the 24th kilograms times the mass of Mars, which is 6.42 times 10 to the negative, I'm sorry, not negative, 6.42 times 10 to the 23rd kilograms. And reflect real quick, notice that this number here, 6.42 times 10 to the 23rd, is smaller than 5.97 times 10 to the 24th, because the times 10 to the thing is the thing that matters more. So yeah, Mars is fairly dinky. It's, about a tenth the mass of Earth, a little bit more than a tenth the mass of Earth. So all of this divided by our answer for part A, 7.8 times 10 to the 10th meters, and that gets squared. So if you put all that in the calculator, F sub G EM is equal to, and the answer is right there, but let me just do it real quick, 6.67 E minus 11 times 5.97 EE 24 times 6.42 EE 23 divided by 7.8 EE 10 x squared, and we get a number 4.20 times 10 to the 16th. And what are the units? The units are newtons. So, yeah, again, real quick, the reason we write this way with scientific notation is because if you were to actually write that out, what you would have would be 420, and then you have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 newtons. And I think I did that right, but the point is, yeah, it's tricky to write out big numbers like that. So that's why we try to avoid it. Did I do that right? Yeah, I did, because 15th would be right after. Okay, never mind, I did that right. So yeah, that's how we do that. And then the last thing we need is, how does the force of gravity between the Earth and the Sun compare to that between the Earth and Mars? All right. So, well, the first thing to point out is, I'm not going to do the math for it again, but the force of gravity between the Sun and the Earth, so F sub G, Sun and Earth, Earth and Sun, is equal to 3.52 times 10 to the 22nd newtons. So this was our answer from the previous one. And we're going to need that because when we do force of gravity between the Earth and the Sun divided by force of gravity between the Earth and Mars, you have to divide that first number by, the thing we just got, 4.20 times 10 to the 16th. So let your calculator do the work for this. What you get is 3.52 EE22 divided by 4.20 EE16. And the number I got in my calculator is 838095 plus some more stuff. So if we keep three sig figs, this really becomes 838,000. So that's our answer for the ratio. And another way you can think of this is this. The force of gravity between the Earth and the Sun is equal to 838,000 times the force of gravity between the Earth and Mars. So what is the physical meaning of this? The physical meaning of this is that even though Mars is pulling on the Earth with its gravity, and the Earth is pulling back, that force is tiny. As big as it is, 4.20 times 10 to the 16th. So this looks like a very big number because it is a very big number. But this number is still tiny compared to the force of gravity between the Earth and the Sun. So what is the even deeper meaning behind that? Well, one of the even deeper meanings behind that is the fact that astrology, different than astronomy, astrology is absolute nonsense. The alignments of the planets has nothing to do at all with life here on Earth. And where the planets are compared to the background stars, that means nothing. Your zodiac sign is ridiculous. It means absolutely nothing. It is utter BS. It is total crap. So yeah, this particular alignment of the Earth and Mars and the Sun might give an astrologer all the warm fuzzies. But yeah, we're physicists. We know better. We know that it means nothing because the force of gravity between the Earth and the Sun is 838,000 times as big as the force of gravity between the Earth and Mars. So that force means nothing. So hopefully you found this helpful.